There's a lot of references out there about the color of shadows. And the color of shadows is a lot more complicated than you might think it be, because you're looking at light mixing versus pigment mixing. So the three colors, red, green, and blue, when you mix those in paint, that becomes black. When you mix that in light, that becomes white. The complement of each of those are different, and you can look at the reference I have for the color wheel for both of those. So we're going to explore the color of shadows. And what you usually hear is the color of the shadow is the complement of the color of the light source. So I'll say that again. The color of the shadows is the complement of the color of the light source. And if you do that experiment yourself, you'll see that it's actually a little bit more involved than that. Light travels in one straight line. So if you have a red light, you're not going to see a cyan shadow. Cyan is the complement of red light. So you're not going to see that. You're going to see a black shadow. So that's very strange, right? Because that's not what you usually hear. What you know, if you're an art person, a physics person, a photographer, you have different perception of what shadow should be. But if you see, the only way to see a cyan shadow is if there's a secondary light source. So if you think about it, we have three colors that we can see that's mixed together to see other colors, other ranges of colors. So we have cones and rods in our eye that allow us to see, the cones allow us to see three colors, red, green, and blue. When all three photoreceptors, those cones, are activated, you see white. So when you're seeing references, you're reading references and you see a still life of the color of the shadows, you need to keep in mind that it's not just one light source, but many light sources in order to see that shadow color. And if it's a straight on simple light source, then the shadow is going to be dark. It's going to be black. So you're going to have, if you have a red light and there's one object, zero other light sources other than that red light, you're going to have a black shadow. And that makes sense, right? Because in physics, you probably learned that light travels in a straight line. Absence of light is dark, then you can't see anything. So that's one point of reference for light. So it's going to be a dark shadow. But if you have a red light and you have a secondary light source like you would have outside, like this, you won't see a dark shadow. You won't see a black shadow. You'll see a cyan shadow. And cyan is the complement of the red light color. We have a secondary light source. We have a red light. I turn off the red light. That will give you just G and B, because the light source gives you RGB. The red light is turned off and is blocked by the object. So that means you only have G and B. G and B combined on the color wheel is cyan, and that's why you see cyan. So it's not just the complement of the light source. You need to think if it is the combinations of the colors that are left. So if you know your three colors, red, green, and blue. And if you mix in the color wheel those colors together, you'll get the color you should see. When you are looking at something, trust what you see, not what you think you know, because it might be that you don't know all the information up to that point. So if you see a certain color and you're thinking it can't be pink in there, it can't be magenta in there, paint that anyway. Now I'm going to go through and show you the other colors. Green gives a magenta color. Look at the base of the object. Try to squint your eyes. The blue gives a yellow color. Squint your eyes again. Look at the base. Reach the end now. Please subscribe and like this episode and let me know if there's anything else you would like to see.